This presentation is about generating test cases, put together by Daniel Blankenship, Nick Nelson, and Nathan Elmer. We would like to do a little review of what a test case is. According to the Holy Internet, a test case is a document which has a set of test data, preconditions, expected results and post-conditions, developed for a particular test scenario in order to verify compliance against a specific requirement. As you can see on this slide, there are a few primary components to a test case. In addition to these listed here, and depending on the tools being used to document and store test cases, there should also be a way to link test cases to the components of the system they pertain to. This link can be stored in a simple document, or a tool can be used to keep track of these links. For example, a lot of companies use Jira and create tickets for issues they need to watch out for, and these tickets can be linked to test cases, and vice versa. Another thing to keep in mind when generating test cases is their statistics. Many test cases will need to be run many times, and it is a good idea to keep track of how many times this test case has passed or failed, and why. There are tools to help you keep track of this information that make it really easy to see which test cases are proving to be valuable. There are several different approaches that can be used to generate test cases. For some people, it is a holy war as to which approach is the best. They each have their pros and cons, which we will discuss. For our presentation, we have decided to focus on 4 approaches that are fairly common in software engineering. These approaches are requirements-based testing, exploratory testing, boundary value testing, and use case testing. Requirements-based testing has an emphasis on integrating testing throughout the development lifecycle, and focus on the quality of the requirement specification. The benefits of this approach are that the length of time required to engineer and implement a system is less, because quality testing is done from the very beginning, instead of after coding has begun. The reason this reduces the project time is because problems with requirements can be found early. If testing is done after coding has begun, and problems in requirements are discovered, then code has to be rewritten. This also has the effect of reducing the cost. Sometimes, however, it is arguably a waste of time to create test cases for requirements. The reason is because some people believe that some projects cannot elicit all the requirements at the beginning. As a result, requirements often change a lot during the development lifecycle of the project. Testing requirements that change would then be a waste of time. Also, bad requirements sometimes have the effect of creating bad test cases. Therefore, this method is best used with projects and teams that can elicit all the requirements at the beginning.
Some of the benefits of using exploratory testing include the fact that the unstructured nature of ET allows the multiple aspects and phases of testing to happen simultaneously, at least in the head of the person doing the testing. Also, as mentioned in its definition, ET testers create varying and diverse tests on the fly in order to reveal as many yet unknown problems in the software as possible. In addition to these time-saving attributes of ET, practitioners of this approach report it to be both effective in detecting bugs and cost-efficient. If there's a downside to exploratory testing, it might be that it is prone to the effect of the characteristics, learning style, and personality traits of the tester whose knowledge and experience are the driving factors of the test. Another downside might be that these tests are not defined in advance in any established test plan. In some cases, this is a good thing, since time and resources weren't expended in comprehensive test planning, but as it pertains to initial project cost and effort estimations, the amount of resources to be devoted to ET would be an unknown. And finally, reports on the effectiveness of ET are based on personal experience, not scientifically documented empirical bases. So if you're building a rocket, don't rely solely on an exploratory software testing approach. So, how can you know that exploratory testing is the right approach for you? ET is considered most effective when used in agile software development processes. It's also considered an important supplementary approach to requirements-based testing, and many other test design techniques can be applied in an exploratory way.
Boundary value testing is the process of testing between extreme ends or boundaries between partitions of the input values. One benefit of this approach is that test cases are generated that only test the most error-prone areas of input domain. The number of possible test cases is then reduced significantly, which reduces the amount of time required to do testing, while still maintaining an acceptable amount of test coverage. The downside is that many possible test cases are never done, and many possible inputs are never tested. Another downside is that some forms of input cannot be tested with this approach. Text input or buttons do not have very good input boundaries, so this approach can only supply a limited amount of the needed tests.
Some of the benefits of use case testing include the fact that use cases are defined by system software requirements, so it's not difficult to come up with a good test case. Another benefit is that real use cases are available in early iterations, encouraging an early start on testing. This way, testing doesn't have to wait until most of the development is done, where bugs are much harder to fix. It's hard to point the finger at use case testing, but if there is a downside to it, it might be that each use case usually requires a significant amount of documentation to describe it. Because use cases usually involve more than one requirement, several test cases are likely to come out of each use case. While UCT is indispensable in any type of software development project, it finds particular utility in development of systems with stringent functional requirements. In other words, when the emphasis of the software being built is more on what it does versus how it does it.
In conclusion, there are a few other things that should be considered when generating test cases, regardless of the approach used. Test cases should focus on one thing at a time. They should also have as much coverage as possible, meaning every possible scenario should be considered. Test cases should use simple and direct language that makes it clear what needs to be done and how. When specific things need to be referenced, it should be clear where to find them and how to use them, and their names should be consistent and exact. Test cases should be traceable to requirements and system components. As mentioned before, tools make it very easy to keep track of this information. And finally, test cases should be repeatable so that they can be performed by a quality assurance team on a regular basis.